Yeah, comes on everyone. Interesting. Perfect. So last thing we did was this. Let's see one more. Let's say we got a rod here, which is 2L, K, A, L, K, A, L, 2K, A. So it's 3 rods. Here the temperature was 2 T naught. Here the temperature is T naught. These are the two interfaces, T1 and T2. So find R equivalent, find the heat flow through the rod, and find the temperature at the interface T1 and T2. And find K equivalent. Same thing as the first one, but there are no two interfaces. So what do you mean by K equivalent? If you replace this entire thing with one single rod, then what should be the Kk value for that? Others do keep your cams on. Okay, we do have R equivalent. If you got R equivalent, you'll get dq by dt. You got an answer, type in the chat box here to the co-host. Get the rest. I'll give you 2 minutes. It's a decent question, a proper mains level question. R equivalent is easy. You can just replace this with 3 resistors. R1 will be 2L length by K into area. R2L by KA. R3L by 2KA. If I take this as R, this is R by 2 and this is 2R. R equivalent will be 2R plus R plus R by 2. 7R by 2. The net heat flow is nothing but temperature difference delta T by R equivalent, which is T naught by 7R, 2 T naught by 7R, where R is L by Ka. Now I'm asking here if the temperature is 2 T naught, here the temperature is T naught. I want you to find the temperature here. I want to find the temperature here. Get them. I'll give you a minute more. See, so this was 2R, this was R, and this was R by 2. This was 2 T naught, this was T1, this was T2, and this is T naught. Now, in all of them, the same current is flowing, where I is nothing but, which we just calculated, 2 T naught by 7R. So, can I say like this? So, I is nothing but 2 T naught minus T1 by 2R. This current, na? Potential difference across the resistor by resistance will give you the current. This is also equal to this current, which is T2 minus T naught by R by 2. Make sense? The total current in the branch is same as the current in the resistor 2R, the current in the resistor R by 2. And what is the current across 2R? Potential difference by resistance. Any doubts on that equation which I wrote? Once you wrote, you're done. So solve these two, you will end up with 2 T naught by 7 was 2 T naught minus T1 by 2. 4 T naught by 7 is 2 T naught minus T1. Therefore, T1 will be 7 to 14, 14 minus 4, 10 T naught by 7. And if I take these two, 2 T naught by 7, this will be 2 times T2 minus T naught. 2T is equal to 2 will cancel actually. So T naught by 7 is T2 minus T naught. So T2 will be 8 T naught by 7. Check. Understood what I did there? The potential difference across the resistor by the resistance will give you the current, which is same as this guy, 290.7R. Because all are in series, the same current will flow through them. You take one resistor, take all resistance, current cannot change. Any doubts on this? Clear? Now the next part is K equivalent. How to find the K equivalent? So now you're saying you want to replace all this with one single rod, right? So this R equivalent was 7R by 2. R is L by Ka, 7L by 2Ka. Now, what is the total length of the rod? Now, this is where people generally do mistake. They take it as L. This is 2L, L, and L. So the total length of the rod was 4L. So you need a rod of length 4L, same area, and K equivalent. So this resistance must be how much? 4L by K equivalent into A. And now you're saying these two are equal. So 7L by 2KA must be equal to 4L by K equivalent into area. Area gets cancelled. We get K equivalent is 8K by 7. Clear with this? That is how you find K equivalent. So the meaning of K equivalent is if you replace the entire system with one single rod of same length, right? It should have same resistance. Any doubts on this page? Please ask. Clear? Next one. This is a rod LKA. This is 2L K area. This is L 2K area. It's a Y-shaped rod. Quite a good question. This will come at least 4 times. Huh? This is the first time. Next time you'll see this thing in fluid mechanics, viscosity. Then again you'll see this in capacitors. Again you'll see this in current electricity. Let this point be A, let this point be D, this point be B, and this point be C. So temperature at A is 3T naught. Temperature at B is 2T naught. Temperature at C is T naught. Find the temperature at that intersection D, find TD, and heat flow through each rod. What is the heat flow in AD? What is the heat flow in DB, DC, and so on? How do we start? Now, when you see this thing, see again, when you see a question, right, it doesn't mean you should get the answer till the end. The most important thing will be to ask the right questions. Most people don't do that. Like, for example, if I'm doing this, the first doubt I'll get is, okay, how the hell is the heat flowing? That's the first thing that I'll think of. One thing is clear, A is the hottest, so heat will go from there. Now the confusion is C is the least temperature, so C will take heat, that is clear. The one I'll get stuck is, I don't know whether B is taking heat or giving heat. Right? So meaning when I'm thinking, that is the thought process. See, the main thing, right, when you're solving a question, you need to keep asking, okay, why is this? What is that? Why did I do this thing? What makes me think this way? When you don't ask these questions, right, you are just being very passive. When you keep asking questions, you will get good answers. Then the confusion comes, okay, I don't know whether heat is going from D to B or B to D. Fair enough. Now think about it. Till now, in every problem that we did, whenever we didn't know something, what did we do? For example, in friction two block problems, when we didn't know whether the blocks are going together or slipping, what did we do? We started with an assumption. Let them go together. In calorimetry, when ice was mixed with water, when we didn't know what happened, what did we do? We assumed. Let the final temperature be 0 degrees. In a rolling motion problem, when a ball is sliding, when we don't know the friction, we assume friction direction. So we do the same thing. We'll assume the direction for heat also for dB. So let's assume heat is going from A to D. Let's call it I. This would be I1. This would be I2. How? I don't know. I'll just assume. So I is equal to I1 plus I2. That much I'm sure. So heat, whatever is going from A to D, will split from D to B and D to C. That is my assumption. And now what is the heat? Heat is nothing but temperature difference by resistance. So A to D will be TA minus TD by resistance L by Ka. I1 will be TD minus TB by 2L by Ka. So high temperature minus low temperature. 2L by Ka. TD minus TC by L by 2K. L by Ka goes off. This guy will be 3T naught minus TD. This guy will be TD minus 2T naught by 2. This will be 2 times TD minus T naught. Bring all T naughts to one side, then you will get 6T naught. Bring all TDs to one side, that will be TD plus TD by 2 plus 2D, that is 7TD by 2. We get TD is equal to 12 T naught by 7. Right, Boris, you got that. Then you're done actually. So what do you want to find? Current in each one. So from A to D, current is I1. I, which is TA minus TD. So that's 3T naught minus 12T naught by 7 by L by Ka. That is 7 3s are 21. 21 minus 12. That will be 9. 9 Ka T naught by 7L. Now from D to B, it's I1, which is TD 12 T naught by 7. Yeah, this is negative, see? So it's fine if you take something wrong. The science will take care of it. I assumed it is positive, but actually B is giving heat. This guy is 7 to 14 minus 2. 2 will cancel. Minus T naught Ka by L. Making sense? So you assume whatever direction you want. Science will take care of it. Similarly, for DC, I2, 12 T naught by 7 minus T naught. That would be 12 minus 7, 5 to 10. 10 K T naught by L. Clear, everyone? You know, you could have done even this actually. You could have assumed current is going from the center in all directions, I1, I2, I3. I know that's not possible, but then what does it mean? Can this point D give heat to everyone? No. So that means I1 plus I2 plus I3 must be 0. You're getting it? You could have done that way also. You could have taken all the heat is coming towards D. It won't matter. You assume anything. Science will take care of it. Have a look at this. Quite a good problem. Again, we will see this in fluid mechanics, viscosity. And then again, you'll encounter this thing in capacitors and current. That's what makes this problem pretty good. Comes in 4 different chapters. Idea is the same. All clear with this? Next one. Clear, na? Adi, Devika? Clear? Parth? Sharman? Got this? Arya? Arush? Next one. We have 100 degrees boiling water. We have 0 degree ice block. Now what you did, you connected these two with a rod. And you placed a heater somewhere here. This point is P, this point is A, this point is B. Now at this point P, the temperature is 400 degrees. Because of that fire, whatever flame you kept, that temperature will be 400 degrees. Maintained by the flame. So the flame is maintaining it. Now, tell me how will the heat flow between A, P, B? Who is the highest temperature? P, right? So heat will flow from P to B and heat will flow from P to A. Na? The heat will flow in both the directions. And now we observe the mass of water vaporizing per second. So every second is equal to mass of water, mass of ice melting per second. Then find AP by BP. Think about it. If you keep this heater pretty close to ice, what will happen? Ice will melt more. If you keep it pretty close to water, what will happen? Water will boil more. So there's a particular point where the mass of ice melting and the mass of water vaporizing will be same. In case you forgot, latent heat of fusion of ice is 80 calorie per gram. You should know this value. So this is based on calorimetry on this. Latent heat of vaporization of water is 540 kilocalories. No, 540 calories per gram. There, good. The question was clear. Same mass is melting, and not same heat. Try, Abhinav, give it a try. Everyone should focus, solve. After the class, you can sit and eat how much ever you want. Solve the problem first. If you're eating and solving, you don't have any problem. Problem is when you're eating with both the hands and not solving, that is an issue. We have one answer. Right, Vihan? Anyone else? One more minute. One. नहीं Janil, you are right. Puruja, that is wrong. Daksha, I think you got reverse. Ansh, I think you also did reverse. On BP by AP. Ishana, you also did reverse. BP by AP. Same thing. Yeah, you just be careful with that. Let's see. So let this side Q1 joules per second heat flow and this side Q2, let's take it as calories. It will cancel out. And this is Q2 calories per second heat flow. Now we know Q1 calories per second, that is a heat flow per second, is temperature difference, which is K. A temperature difference will be Tp, that is 400 minus 100 degree. This for the boiling water. By length is AP. Right? And what is Q1 equal to? Q1 is boiling water, so M1, M into latent heat of vaporization. This is M into L vaporization. Now for the ice, Q2 calorie per second, which is K. A temperature difference is 400 minus 0 degrees. So the temperature difference is also not same. Pi BP. You getting which formula I'm using? Ka delta T by L. Right? Conduction, there's only one formula. If you see, whatever I taught you till now, we are just playing with this one formula, Ka delta T by L. I didn't teach you anything else. This is equal to M into latent heat of vaporization. Divide them. When you divide them, Ka will cancel. You will end up with 300 by AP. This will be 400 by BP. This will be LV by LF, which is 540 by AT. So BP by AP, 3 by 4, 54 by 8, 4 za, 2 za, 2 za, 27. There, so BP by AP is 9 is to 1. AP by BP I asked you, the 1 is to 9. Clear? Easy? There, a little bit of a calorimetry plus conduction. Any doubts on this? Next one. Clear now, just got a mistake. Yeah. Others see where it went wrong. You have 7 identical rods. All are L, K, A. Same length, same K and everything. This is A, B, C, D, E, F. Temperature at A is 2 T naught. Temperature at F, T naught. Find R equivalent. Find the heat flow, dQ by dt. And find temperature at BCD. So heat is flowing from A, then it splits between BC and goes. Find this. Hmm. What is this? Do you remember? This is a Wheatstone ridge. That rod CD in the middle can be removed, na? Because if you see this resistance by this and this, the ratio is same. That was the third thing I taught you last time: series, parallel, and Wheatstone ridge. Remember this? If the ratio of the resistance are equal, you can remove the central rod. Then it becomes easy to solve. So you can replace this with resistance. And there are more variations. We will see that in current electricity. But in this chapter, this much is fine. There. So everything is R, 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 where R is L by Ka. If you see, this is the Wheatstone bridge. You can remove the thing in the middle. Then your circuit becomes like this. Then this becomes like this, R, R, and R. Because see, this R and R, 2R, 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 2R will be R again. So you'll end up with R equivalent is equal to 3R. And dq by dt is equal to temperature difference T naught by 3R. Clear. Now, how to find the temperature at BCDE? Try, I'll give you a minute for that. If that extra part is not removed, now you can't solve this. There are techniques to solve, but not right now. We will see those things in current electricity. By T by 3, 4T by 3, that is right, Ishana. C and dp nikal do. How do you find the temperature? Let's see. How can you get 5 T naught, right? Temperature 2 T naught and T naught. You created a higher temperature source. Again, you all are pioneers of free energy. See. Abhinav, you can finish off eating and then rejoin the class, right? No, that I think would be better instead of you're focusing. So I'll remove you. Go eat and half an hour ke baad aaram. If you need rest also, you can sleep for half an hour, take a break and come. Yeah. Bye. Happens sometimes people are hungry during the class. So they start eating with both the hands like a monkey. And then this is a 2T naught. This is TB. This is TC. This is TD. This is TE. This is TF, which is T naught. Now, how is the current flowing? The current is flowing here I just now we calculated, which is T naught by 3R. That's the dq by dt, the whole heat flow. Current is splitting here, I by 2. Current is splitting here, I by 2. Then current is splitting again here, I by 2. And again it splits. That is I by 2 and I back again. Is the current distribution clear? Because of symmetry, the current splits there. So now when you go from A to B, the current I is temperature difference 2 T naught minus TB by R. This is nothing but T naught by 3R. RR cancels. We get TB is equal to 2 minus 1 by 3, 5 T naught by 3. Then you go from B to C. You can actually guess, B to C. If I draw a line here, can you see left and right are looking identical? Whatever is happening on left, same thing is happening on the right. Can you see C and D are midpoints? So that will be 2 T naught plus T naught by 2. You could have guessed it, but yeah, let's calculate. So current will be I by 2 is TB minus TC by R, which is T naught by 6R. TB is 5T naught by 3 minus TC is T naught by 6. So we get TC is equal to 3T naught by 2. Same way, symmetry, D is also same. That is the whole reason why you removed the rod CD, isn't it? Because C and D are same, you can remove the rod CD. Then you can do for EF. I is equal to TE minus TF is T naught by R is equal to T naught by 3R. We get temperature T is equal to 4 T naught by 3. Check. Any doubts on this thing? Any step you're not clear? Next one.
1 minute.
Clear, na? Devansh, Adi, Taksha, Sharman, Soham, Ojas, Parth, clear this. Vignajit, clear, Arish? Next one. So we have two parallel plates. So the upper part is filled with material K. The lower half is filled with 2K. The distance between the plates is D. And this area is A by 2 and this area is A by 2. Basically, it is half of the plate. So heat is flowing from left to right. Same thing. This time the left half is filled with K, the right half is filled with 2K. This is d by 2, this is d by 2. Area of the plate is A. And the diagram would have looked like this. This is K, this is 2K, this is 3K. So this area was A by 2, A by 2. This was D by 2 and D by 2. Find R equivalent. So in the first case, upper half, and it's not a cuboid. Area de diya na, distance is D and area is, it's not a, it's a three-dimensional thing, yeah. Meaning this entire thing is filled with that. The entire upper part is red one. Are you getting the diagram? The room you're sitting, the entire upper half of the room is K, lower half is 2K. B question, left half of the room is K, right half of the room is 2K. It's a 3D structure. C question, left half is K, right side mein up is 2K and bottom is 3K. Third is a very important question. This you will see in another two more chapters, capacitors and current electricity. And this thing came in yesterday, JEE Mains ka first paper. Question C. One of his senior calls up and says, "Sir, remember that capacitors question we did in the class?" I said, "Yes, that came in the exam." I said, "Good. Did you do it?" "No, sir, calculations are lengthy. I left it." I said, "Bloody, why the hell did you even call in the first place to tell me that it came then?" So your seniors are also weird only. 'Anyone got the diagram? Let's get the A and B first. Think for a minute, then I'll show you one. Two D by SDK. Let me show you one. So this is what I can do. I can replace this, the upper half like this and the lower half like this. Can I split this into two pieces? Like this. Where this entire upper half is filled with K, the lower half is filled with 3K. This distance is d. This area is a by 2. So I can write this as two resistors. They're series or parallel? Parallel, no? Why? Same temperature difference, isn't it? Left and right plate ka temperature difference is same. So they're parallel. So this resistance will be D. Length is D here. L is the length along the heat flow. By K, area is A by 2. This is D by 3K, 2K that is. D by 2K, area is A by 2. Both are in parallel. So R equivalent will be R1, R2, 2D by KA into D by KA. R1 plus R2, 3D by KA. D by KA goes off, 2D by 3KA. Make sense? Current flow from K to region to K. We will assume, will not take those cases. So generally you can assume like as if there's a thin gap there. But logically also, if you think about it, see, this point, this point, this point, this point, they all are at same potential, isn't it? Same temperature. So heat, there is no heat flowing like this. Right? All of a sudden you can't have heat like this and taking a turn this way.
So at least at the point where they meet,
And we will ignore those things. The edge effects we'll ignore. Technically there would be, we'll ignore that edge effect. We can say there's a thin air gap between them. What about B? So this guy can be written as like this, the left and right. This was K. This was 2K. Area was A and the length becomes D by 2. Both are in series, so R equivalent will be D by 2KA plus D by 2, 2KA, 3D by 4KA. Since it only 1D, the areas are same. 1D, which one are you talking, Jainal? One dimension. Array, in the formula L by Ka, what is L? L is the length along the heat flow, na? Heat is flowing from left to right, right? So this is the length, right? Na? The plates are left and right, na? So heat is flowing from left to right. Agar heat is flowing from up to down, then this is the length, na?
Okay. Yes, sir.
That length depends on which way is the heat flowing.
Okay.
What about C?
Sir, can you show the B part once more?
Hmm.
Okay, thank you.
How do we do this? Now, when you see this, the first feeling is this. This was K, this was 2K, this was 3K. This is a blunder. Okay, that's the first thing. It's a blunder. And that is the reason your senior remembered it so well. Because I must have told this thing at least 10 times before the thing. This guy still went and forgot. He knew how to didn't do, but he forgot how to do. The catch is this. Now, tell me one thing. Let's say if you're going from Mumbai to Pune and there are two roads. The first half of the road is a very good highway, then the road becomes bad. The second road, the whole road is a highway. Now, can you see the first half looks the same? Just because the first half looks the same, do you think the same traffic will flow? So, if you look at here, K and 2K, here K and 3K, do you really think the temperature at this interface, the black one which I drew there, and the temperature at this interface, the sky blue thing, you think the temperatures will be same? Temperatures won't be same. That much you agree? Because upper K2K, niche K3K. There is no symmetry. Temperatures need not be same. If temperatures are not same, let's say if this is T2 and if this is T1, then is this temperature difference and is this temperature difference same? Temperature difference is not same. Then they're not in parallel. Na? Just because you're side by side doesn't mean you're in parallel. The temperature difference has to be same. Is that making sense? Since the upper and the lower interface are not identical, lower half are not same. The interface, the upper and the lower interface will have different temperatures. Therefore, 2K and 3K are not in parallel. That is the thing. Then how to do? Can I split this into 4 pieces? Now can I say whatever current flows in the upper part will be same in K and 2K? And whatever flows in the lower part, K and 3K will be same. So the upper two pieces are in series, the lower two pieces are in series, then the total up and the total bottom will be in parallel. Is that making sense, everyone? The same current will flow in the upper K and 2K, agreed? Same current will flow in K and 3K, agreed? So upper two pieces are in series, bottom two are in series. The total upper and the total bottom is in parallel. Total. Because they have the same plates, na, left and right. Is that making sense, everyone? So this would be K, K, 2K, 3K. Where area becomes A by 2, length becomes D by 2. Now can you try? Get this. I'll give 30, 40 seconds. Just calculations now. So there are 4 resistors. This will be d by 2, Ka by 2. So this will be d by Ka, d by 2Ka, d by Ka, and d by 3Ka. The upper one will be 3d by 2Ka. The lower one will be 4d by 3Ka. R equivalent is R1, R2 by R1 plus R2. That will be 3 by 2 into 4 by 3. 3 will cancel. 2. Denominator में 3 by 2 plus 4 by 3. 9 plus 8, 17, 6, 12. There. That's your answer. Clear, everyone? Question is still not over. I can still ask you more. So we said the upper and the lower interface will have different temperature T1, T2. Can you tell me who is bigger, T1 or T2? Now, if I ask you that, suddenly it becomes an advanced more than one choice question. Now, I can ask multiple things on that. You're saying they're not in parallel because there are 4 parts. Would we do it? You're saying यहाँ पे भी एक और piece डाल दोगे ऐसा? And then you'll take 3 branches, na? Like this, like this, like this. You're saying यहाँ पे भी also it is different. Then fine, na? What is the problem? This still works, na? 4 branches. See, even if you take this is different, end of the day, this and this will be in parallel. The total upper, total lower are always in parallel because same plates, hai na? Problem is the middle. Can you find T1, T2? Get them. I'll give another 2 minutes. There cannot be temperature difference across the plate as it is one plate. It's a conducting plate. The overall plate will have same temperature. Perfect conductors. They'll have same temperature. Can you find T1, T2? यहाँ पे temperature 2 T naught ले लेना and यहाँ पे temperature T naught. So this is 2 T naught and this is T naught. This is T1 and this is T2. Find T1, T2. That would be another question. Who will have more temperature, the upper half, upper interface or the lower interface? Any answers? Let's see. Anyone got it? This becomes like the first question, isn't it? This is like R. This is like R by 2. This is like R, and this is like R by 3. This is 2T naught. This is T naught. Let this current be I1. Let this be T1. This current is I2. Let this be T2, and this is I2. So we can write I1 is nothing but 2T naught minus T1 by R must be equal to T1 minus T naught by R by 2. Is this what we did in the first problem? You can do it separately for the upper branch and the lower branch. RR will cancel. That would be 2T naught minus T1 is 2T1 minus 2 naught. 4T naught by 3. Similarly for the lower branch, 2T naught minus T2 by R. T2 minus T naught by R by 3. This will be 2T naught minus T2 is 3T2 minus 3T naught. This is 5T naught by 4. This is 1.25 T naught. This is 1.33 T naught. T1 is greater. For K1, can we have separate different charges as a resistor? What are you talking?
So like we said that
What is K1?
So that K1, that whole resistor in the first one.
Upper branch.
So there's a K1 that's in both branches, right?
Where is K1? K, red wala.
Yes, sir.
Okay.
So there is a temperature difference or current
Where?
difference, you can say.
Upper and the lower of same current won't flow.
Yes, sir. So that is possible because it's a resistor, but it can't be possible in a plate.
What plate you're talking about?
So like the previous question I asked, that is.
The plate was this thing, na? These blue things are the plate.
Yes, sir.
That will have same temperature. It's a conducting plate. K is infinity.
But sir, in resistor, it is possible.
What is possible?
That same different temperature.
Yeah, you can have Q.
Okay, so just wanted to
Like, what
confirm
is so
this.
special about a resistor? Like, why can't you can't have two different temperatures? Why can't this flow differently and this flow differently? That's what I'm saying now. What if you made two roads where the first half is identical, but the second half is messed up? The first half looks same, na?
Yes, sir. Same
Doesn't mean the same. Simply as a socho na, when you're going on a highway, right? Let's say for some reason this part of the road suddenly becomes a 3-lane. Did you ever see this?
Yes, sir.
The cars in this lane go slower than the cars in this lane. कभी observe नहीं किया?
Yes.
And it doesn't just start here, huh? This thing will actually start somewhere half kilometer से start हो जाएगा ये. Next time observe this. Whenever if 4-lane converges into a 2-lane or 3-lane, it gets messed up. And Mumbai is famous for this. They think they're always building roads, but they're doing nothing. They're just simply shifting the traffic from one place to another place. One of the best example is the Sea Link Road. Ever been on the Sea Link Road? Bandra Sea Link. That's a very beautiful, I think, 4 or 6 lane, right? It's a pretty big road. But if you observe, the final exit which comes out, right, that is only 2-lane. No matter how fast the car goes, at the end of that, you will get stuck in this bottleneck. So it's always like that. So if you look at Mumbai, this is how they always do nonsense. They don't think too much. Yeah, they think it will get sorted out. So initially, Bandra was something like here. So when they built the Sea Link Bridge, all the traffic that is getting jammed here, now it is getting jammed here. So they're simply shifting the traffic to the north. Now they're putting the coastal road. So traffic will go here. Now that will get blocked somewhere here at the exit. The traffic will always keep shifting to the north. The whole point is if you shift it enough north, maybe there won't be enough traffic. At least Mumbai में नहीं होगा ना. Let
Yes.
Borivali, Kandili people sacrifice. Clear with this. Next thing. Next one. That's a good one. Let's see some theoretical questions. You took a metal and a wooden block. And are placed in a hot room. Hmm. Who has more temperature? After a few seconds, after a few hours. Hmm. Let's see. See. Now, if you see, the metal initially will absorb heat faster because it has high conduction, and temperature will rise faster. But can it exceed the room temperature? It cannot exceed room temperature, isn't it? That means eventually metal temperature has to reach room temperature. Now, when you put wood, what is the difference? Wood will absorb slowly, but if you keep it for long enough, what will happen? It also will reach the room temperature. So initially, metal absorbs heat faster. Since high conductivity. And finally reaches room temperature. You cannot exceed your room temperature. So the only difference between wood and metal block is wooden block will take time. So if you try to plot the graph of temperature versus time, and let's say this is your room temperature. So the metal would be like this. It goes pretty fast. Whereas wood will take time gradually, but eventually it will also reach because of low conductivity. You're getting it? So just after a few seconds, what will happen? The metal will have more. But if you keep it long enough, both will be same. Okay? That is the difference there. Next one. Suppose we have a container which has boiling water. You have some heater also, so you're maintaining this continuously. Now what you did, inside you dipped a metal glass with water. Did you ever, I don't know whether it happened with you, let's say you're going to the school, it's getting late, your mom has boiled some milk and it is still hot. Then I don't know whether your mom must have done that. Yeah, she must have kept the milk in a glass and kept it in a water, floating like this. It cools down faster. Ever happened? I used to get irritated. I used to keep it in the fridge. So nowadays, too, I'm more smart. I put ice blocks inside, and I think it is cold milk, and I drink. There's no point in boiling. So the point is inside you have some water to cool it down. So my question is, will this water boil or not? Meaning, will that become steam? Is my question clear? You have a big bowl, container of water boiling. In that, you kept a metal glass. In the metal glass, there is some water. Now, this metal glass is floating because it's not completely filled, the green one. So the question is, will the water inside the glass, the green stuff, will it boil or not? If you put ice, yeah, it dilutes the milk. No, that's not the point. Solve this question. Closed. What is closed? कुछ closed नहीं, सब open है. The big one is open, the glass is open, सब open है. Take some time. Nope, it doesn't boil. Why? Think about it. One is the temperature, the metal glass. As the heat is getting transferred inside, at some point, the water temperature will reach 100. This also will reach 100. When the temperature inside is 100, outside is 100, what is the heat flow? Zero. Now, to boil the water, you need extra heat, na? Isn't it? To vaporize water, for every 1 gram, you need 540 calories of heat. Where is this heat coming from? Whatever heat the glass gets must get through these walls only. Do you agree? The green stuff, the whatever heat the green stuff will get, it will get only because of conduction. Everyone agrees with that statement? The heat has to pass through the metal glass and then reach the green part. But if inside and outside the temperature is same, there's no net heat flow. So whatever heat is going in, the same heat is coming out. Net heat flow is zero. Therefore, there is no heat exchange. Therefore, there is no additional heat to vaporize the water. It will not boil. It will just be at 100 degrees. Does that make sense? Meaning, so now, let's say inside is 90, outside is 100. What will happen? Heat will flow. 99, 100. What will happen? Heat will flow. 100, heat will flow will stop. Once the heat flow stops, there is no extra water. The water will be at 100, but it won't boil. Yeah. It will keep on boiling. Why is that boiling? Because of this heater, na? This heater is giving you heat, and that's why you're boiling. But for the green stuff, the heat has to go through the metal glass, but that won't happen because inside outside temperatures are same. Everyone clear with this? Making sense? Next one. Any doubts on this? So theoretical questions will be like this. Not tough, but you need to think of it. Meaning, if I ask you one more like this, imagine it is winter, pretty cold, right? You have two options. I have one blanket of 2 centimeter thickness. I have two blankets of 1 centimeter thickness. 1 centimeter, 1 centimeter. Everything is same. The material, the area, everything is same. Only the thickness is different. Right? I have two blankets, 2 centimeter and 1 centimeter and 1 centimeter. Right. So, question is, which is a better option? Which one should you choose? Just that way you can make sure temperature is maintained. If you keep the outside water at 50, inside will be 50 only. No, you can't exceed that. Meaning, for example, by chance, imagine this heater also generates too much heat, which you can't control sometimes. Still, you're safe inside, isn't it? Yeah. So this is a standard question. So what happens is when you take this 2 centimeter thing, when you put a blanket over a blanket, some of the air gets trapped inside. That air, the layer in the middle, will act like a third blanket. And air is a bad conductor. So two thinner blankets of 1 centimeter, 1 centimeter will produce more insulation than a 2 centimeter blanket. Because the air trapped between the two layers will act like a third blanket. And air is even a bad conductor. So it actually gets pretty hot. You should try this with two blankets. Yeah, that's the CET type questions. Let's see one more. We have a cylinder with a thickness, inner and outer radius like this. This is A, this is B, this is K, this is length L. So heat is given here, T1 and T2, left and right. Find R equivalent. Get this is an easy one. What is R thermal? L. L is the length along the heat flow. How is the heat is flowing here? Left to right, na? Length. K, what is the area? Now, if you see here, the heat is flowing only in this area, isn't it? The heat is flowing in this area. That will be pi into B square minus A square. Plus, itna hi karna tha. Easy. The definition is important. L is the length along the heat flow, which is left to right, L, and the A is the area perpendicular to the heat flow. Clear. Take a break. We'll start at 7:03 again. So take a 10-minute break and come back. We'll continue from here. Now, from here, integrations will start. Any doubt so far?
So,
That's
so in the eighth question, the second part,
uh-huh.
can we like say that it is boiling, but the air around it that will also absorb some heat. So like, can we say
No.
what exactly?
Boiling nahi ho raha hai na. See, to boil you need extra heat. Agreed. After reaching 100, if I give you extra heat, you will boil.
Yes, sir.
The question is, where are you getting the extra heat from? The only person who can give you heat is the surrounding water. Agreed?
Yes,
But your surrounding water ka temperature and my temperature both are same. If there's no temperature difference, heat won't flow through the metal glass.
yes, sir.
That's okay. So there is nothing there. There is no extra heat, so I can't vaporize.
Yes, sir.
Okay.
Okay. Yes, sir.
Next one. Same thing. This time the inside ka temperature is T1, outside ka temperature is T2. Means now the heat is flowing this way, radially. This is A, this is B, length is L. Temperature differences between inner and the outer surface. Find R equivalent. So depending on where you apply temperature, distance changes. And this is for L is much greater than B minus A. It should satisfy this condition. We will see that. What happens if that condition is not satisfied later on. But first, let's get R equivalent. R equivalent, right? Why did you get T2 minus T1 in R equivalent? Even then, that is wrong. Abhinav, any answers? What is the problem here? When you say L by Ka, what is changing? As the heat is flowing out, if you see the heat flow here, see the side view will look like this. The heat is flowing radially, isn't it? So as you go out, what is changing? Area is becoming bigger and bigger, na? You cannot use the formula directly, L by Ka. A is not constant. So what we do, we take a very thin cylinder. Whose radius is x, thickness is dx. So cylinder is so small, we can assume the area is almost constant. The heat is flowing like this. Now, can you tell me what is the length? In the formula L by Ka, what is length? Length along the heat flow, which is dx, na? Heat is flowing across a thickness of dx by K. What is the area? 2 pi x into L, na? The surface area of the cylinder. A is the area perpendicular to the heat flow. Is this making sense, everyone? How did I take the element? So consider a thin cylinder of thickness dx and radius x. So now if you add all these thin cylinders, you'll get a thick cylinder, right? Consider a thin cylinder of radius x. Now tell me one thing, all these cylinders are in series or parallel? Is the same current flowing through all of them? Whatever flows the current heat, the same heat will flow. So all are in series. So these cylinders are in series. Why? Same heat flow per second. Therefore, R equivalent will be summation dr. That would be 1 by 2 pi kl integral dx by x. Limits will go from a to b. That's ln b by a. 2 pi kl. That's your answer, everyone. You'll get a ln. So as you go out, the area is increasing gradually. Now, this is valid only if L is much greater than b minus a. What's the problem? We'll see that. But have a look at this. Any doubts on this integration, please ask. So in the formula L by Ka, L is the length along the heat flow, which is the radial. Chalo, wo b minus L le lenge. When you say K, what will you take area? Tell me. Length we will take b minus a. Okay. Length is flowing from here to here, so I'll take this as length. What will you take area? Will you take the inside area or outside area? Isn't it? Area is changing continuously. Clear with this? Everyone? Jainil? Puroja? Ishana? Clear with this? Vihan? Now, what is the catch with this length much greater than b minus a? Suppose if L is comparable to b minus a, we will start having issues like this. Center may it is still fine, but as you start going to the edge, the heat will start going like this. Getting it? Heat is not radial near the edges. So what is the problem? If heat is not radial, what is the problem? What is the area? A is the area perpendicular to the heat flow. Then can you take area is equal to 2 pi xl? Area won't be 2 pi xl, na? If the heat is not radial, the surface area won't be perpendicular to the heat flow. Making sense? Therefore, surface area is not perpendicular to heat flow. You can't solve the problem. Clear with this? But when you take the length is very small, even then there is a edge, there is a problem, but you can ignore it. It is too small. So when you say L is much greater than B minus A, we are actually looking at something like this. We got a cylinder with a very small thickness. That small difference we are talking about. The thickness is very small, B minus A. So here the edge effects can be ignored. This is also technically it is called fringe effect. Fringe is meaning edge. Clear? Let's see one more. Any doubts on this? Now, these things are important, you know why? Mains mein they won't touch like this, but advanced mein they'll give like this. The heat flow is this for all lengths. for L greater than B minus A, for L less much greater than B minus A. So there'll be options of that sort. Then people won't understand like why the hell the n should be bigger. Soham, clear na? Clear, Abhinav, Ansh, Adi? Next one. We have a solid sphere with a cavity. Now, technically, you can't see the cavity because it's a 3D structure, but they're on a paper I'm showing you. Now, the inside ka temperature is 2 T naught. Outside ka temperature is T naught. So heat is flowing again radially. The inner radius is A, outer radius is 2A. This entire material in the middle is filled with a conducting material K. First question. Find R equivalent, find dq by dt. Find temperature at a distance x. X from center, where x ka value lies between 2A to A. So when you go from A to 2A, how does the temperature vary? If dt by dx is proportional to x power n, find n, that would be an integer question. What else can I ask you? Let's get these three first. We'll see. We can ask more, but I think if you got this, you'll be able to handle most of it. This would be a paragraph question. And quite an important one, because the same thing again you'll encounter in capacitors. Literally, conduction, whatever you do, you will see all these questions in capacitors or current electricity. That's the best thing about this. The ideas and the techniques are same. Only in place of temperature, we'll call it potential there. In place of heat, we will say current, but everything works the same. Get the first one. If it is a mains level question, I'll ask you C. If it is an advanced question, I'll ask you dq by dt and B. A and B questions. Negative. You goofed up something. R equivalent, you got negative. dx by x square integration क्या होगा? -1 by x. The minus goes off. Right, Vihan. Get the temperature. That would be a better one. One by 12 pi k a square. Near है? Square नहीं आएगा. You have to integrate. Did you even integrate? Okay. Get the first part. I'll give you 1 more minute for the first part. Right, Daksha. Right, Puruja. See the first part. Actually, they're all kind of related. So from the at a center X, say I will take a thin shell. There I took a thin cylinder, no, I'll take a thin shell here of radius X and thickness dx. Because here also the same problem. As you're going out, the heat is area is increasing continuously. So for the first part, so dr length will be dx by k. Area will be 4 pi x square, na, the surface area. All these things are in series. So R thermal will be 1 by 4 pi k integral dx by x square. Limits will go from a to 2a. That will be minus 1 by a. So this is 1 by 8 pi ka. dq by dt will be temperature difference delta T by R equivalent. This will be 8 pi ka. Temperature difference is 2 naught. There, first part आ गया. How do you find temperature? Temperature at a distance x, and if dt by dx, remember what is dt by dx called? Temperature power ranger. No, temperature what? Gradient. Don't forget. Not a bad name, temperature power ranger types. Okay. Let's get this. How do you find the temperature at a distance x? Into x minus a by x. So if you put x is equal to a, are you getting 2t naught? Isn't that how you check your answer? If you put x is equal to, you are getting 0. If you put, okay, if you put x is equal to 2a, are you getting t naught?
So there should be plus sign there first.
चलो भाई ये plus डाल दो. If you put x is equal to 2a, are you getting t naught? Don't set up the answer. Solve करना. कहाँ से आया? Did you solve that equation and got it, or did you
Yes,
use your
sir.
super mind power and solve it?
So no head power.
You should use physics, everyone. Don't use your mind power, brain power, God power. No, those are not allowed. Only physics. So that is a wrong answer, though. Think. I'll give you a minute more. It's a good one. It's okay if you don't get it, but try. Like, see, I know dq by dt is equal to minus ka dt by dx. Remember the differential form? We have your differential form, na? I told you if something is varying, always use the differential form. Actually, na, the c part also will come from here now. See, what is dq by dt? 8 pi k naught. 8 pi k t naught into a is minus k. What is the area? 4 pi x square dt by dx. There, you can, from here you can clearly see dt by dx is proportional to 1 by x square. So that is x power minus 2. So आ गया ना, third part भी आ गया. That's why this I said this was a mains level simple question. Tell me one thing, when the heat is flowing, dq by dt is constant, right? We'll directly get dq by dt is 1 by a, proportional to. Now here 4 pi will cancel, so this will be dt is equal to minus 2 a, k will cancel, t naught dx by x square. limits will go from a to x. This will be from 2t naught to t. Making sense? When x is equal to a, limits are not from 0 to a. Temperature is starting, material is starting from a, right? And it is ending at 2a. You want temperature at an x, so limits will go from a to x, and the temperature will go from 2t naught to t, because when x is equal to a, temperature is 2t naught. This guy will be t minus 2t naught. This will be minus 2a t naught minus 1 by x, so plus हो जाएगा. This will be 1 by x by 1 by a. 2t naught will actually cancel. You end up with 2t naught a by x. Check. It's a decent answer. When x is equal to a, I got 2t naught. When x is equal to 2a, I get t naught. Yep. The temperature is varying as a 1 by x function. Clear with this? It's actually a hyperbola. Now they can ask you further more, but have a look at this integration. हाँ प्रतीक बोलो ना. Can we find Rx and use delta? Yeah, you can do that again. आएगा same answer. But it'll go little lengthy. वही तो किया ना? When you're finding Rx, you limits are what from 0 to a to x ना? You will get the same thing. That will go long actually. That is one way to do, not wrong. Clear? Now, another way of asking, right? Suppose in this only, if they ask you to draw the graphs, dq by dt versus x graph, if they ask you to draw the graph dt by dx versus x graph, temperature versus x graph, कैसे दिखेगा graphs? How will dq by dt look like? What is dq by dt? Heat flowing per second. As you go out, will the heat flow increase or decrease? Same, right? No matter how much you travel, the amount of heat flowing is constant. So the graph will be a constant straight line. Graph will start at A, end at 2A. It's a constant line. What about dt by dx? This though we saw dt by dx is equal to minus constant by x square. So this graph would be something like xy square is a negative constant. Meaning, chalo, if I take mod here, then the graph would look like this. It's a decreasing function. Interestingly, temperature also will look like a hyperbola only. T naught 2 T naught A by X. Problem is that you can't tell the difference between B and C graph. They look kind of same. But if you actually try to compare them, this graph actually is more steeper. It falls down much faster. That much you can say. But in terms of looking, they look kind of similar. If this is the green line would look like this. That one is more steep. It will just go more. This is a hyperbola. That is another way of asking graphs. But again, to get that, you need to know the mathematical part. Clear? All clear with this integration? Should definitely try this again on your own today or tomorrow. These things look like you understood, but when you take this out and solve, you will realize something is missing. Because exam manner, they won't ask like this, they'll change. They'll say k is equal to k naught x square. Then what will you do? Okay, na naya question. I can even change k ka material also. K need not be constant. Clear? Next one. A truncated cone or a frustum. So this is A, this is B. So heat is going from left to right. So this was 2 T naught and T naught. Find R thermal. Quite an important question, comes in 3 chapters again. Comes again in current electricity, comes again in elasticity. So there we are going to skip the integration. We are going to do it here. Find R thermal. This is valid for L much greater than B minus A. We will see why that condition is required. Did everyone get the shape? Area is not same. It's like it's a cone, part of a cone. It's cut off, truncated cone. Let's get this. Pretty good result. You should definitely mug up the result though. Mains mein, bits mein, if this comes, you should just mark it. It does come. It's a mains, bits mein, it's a direct question in the exam. Let's see. The problem is, again, what is the problem here? When the heat is going from left to right, what is the length? Length is L. K is K. Problem ye aayega, what is area? You're getting it? See, when you're solving questions now, when you try to solve it, this is how you need to ask. Okay, R thermal, see, this is what I was saying. This is what I think. Okay, I need to find R thermal. The formula is L by K. Great. Do I know the length? Length is L. Do I know K? Yeah, K is there. Area. Now I get confused. Should I take this area? Should I take this area? Every instant area is changing now. Once I get that confusion, I know, boss, this question is not a normal one. I have to use integration. Some of you have that problem, sir. How do you know that you have to integrate here? Getting it? So in the process of solving, you will get stuck and say, I don't know what to do with this. It is changing. The moment you use the word, this is changing, you're done. It's calculus involved. So the problem we are having is the same thing. Area is messed up. So let's do like this. At a distance x from here, you can take a thin disk. That's how we take elements. Can you find this radius r? Find that. I'll show you from there. At a distance x from the left side, let a thin disk be taken whose radius is x. X is changing now. Can you find that radius in terms of x, a and b and l? What is the radius of a disk at a distance x from the left side? Everyone understood what I'm asking? Can you get that radius? It's more of a geometry than physics. Get it? So what I was trying to do now, so resistance dr will be length, which is dx, by k, area will be pi r square. So I need to find that small r. Without that I can't solve. No, Vihan, that is wrong. Once I know that small r in terms of x, I am done. I can substitute and integrate. Fine, get that r. I'll give you a minute. Let's see. See, if I treat this point as origin 0, 0, this point will be 0, a. This point will be x, r. This point will be L, 0. And this point will be L, b. Can you see this? All these 3 points are on a straight line. If 3 points are on a straight line, what is same? The slope. The slope will be r minus a by x minus 0 is b minus a by L. So we get r is equal to a into b minus a by L into x. That is one way to do a straight line equation. Or you can say the line is a linear function. You can say r is equal to cx plus d. When x is equal to 0, r is equal to a. When x is equal to L, r is equal to b. Substitute and find c and d. That's another way to do. Or you can drop a perpendicular like this. This angle is theta. Tan theta is this side by this base. Tan theta is also this by this, na? Which is actually the slope, isn't it? Tan theta is the slope. You could have done that also. Is that making sense? So there are multiple ways to figure it out. See which one it works for you. So once I get this, dr will be dx into b minus a by L. Substitute here. So dr will be L by b minus a into k by dr by r square. Integrate on both sides. So this would be r thermal L by b minus a k integral dr by r square. Limits will go from a to b. That would be minus 1 by r. Minus 1 by r. Limits will go from b to a. Simplify this. You will get k into pi ab. B minus a cancels out. I can show you that. This would be b minus a by ab. There, you get a pretty neat answer. R thermal is L by k pi ab. The answer looks as if the area is the geometric mean of A and B, pi ab. It looks like that. Clear, everyone? So, is the integration clear? Let me just put down here. So R thermal is L by K pi AB. Definitely mug up the result. This is valid if L is much greater than B minus A. Again, what is the problem if L is comparable? If L is comparable, how will the heat flow? Heat will flow like this, isn't it? So do you still think this area is perpendicular to the heat flow? That's the problem. Area will not be perpendicular to the heat flow. Area pi x square won't be perpendicular to heat flow. You can't solve the problem. Clear. So it has to be very small. So you can, it kind of looks like cylinder. So if L is much greater than B minus A, the shape would look like this. Meaning you can't really tell the difference. Like there, we are talking about this small difference. It's almost like a cylinder. These kind of problems, now this is the problem. You have to be careful. If you take too broad, the whole thing gets messed up. The area won't be perpendicular, you can't solve. So there are certain assumptions. So the results are not like always valid for everything. Clear? Any doubts on this? Anything that is not clear in the integration? So idea is the same. The area is changing. So I got that radius in terms of x and substituted there. Next one. Clear, na, Daksha? Next one. We have a container insulated. Mass and specific heat, temperature is 2T, not liquid. So insulated meaning heat can't escape through the walls. Now what you did, you connected a rod here, length L, K, area, and this right end ka temperature is T0. It's maintained constant. So what will happen here? The heat will flow from the liquid through the rod and will escape through the rod. No? If the heat is escaping through the rod, what will happen to the temperature of the liquid? It will decrease. If the temperature decreases, the heat flow will decrease. You're getting it? So find the temperature of the liquid after time t. The liquid in an insulated container. Is in contact with the rod. The other end is maintained at T0. Find the temperature of the liquid at time t. Any guesses? Meaning, if this question comes in the exam, how do you guess? There'll be 4 options. How do you see the options and guess? Inky, pinky, ponky, father has a donkey. That doesn't work. What to do? If there are 4 options, what will you do to guess like boss? This is way to I guess. That is one. If you put time 0, kya aana chahiye? At time 0, what's the temperature of the liquid? 2T0. So in the 4 options, put T0 and see who is giving 2T0. Whoever is not giving is wrong. Maximum one option will get eliminated. Generally, you don't get more. Ansh is also saying, sir, function should be decreasing. वो भी ठीक है. The temperature should decrease, right? So there should be a decreasing function. What else can you do? After a long time, what will happen to the temperature of the liquid? If you keep it for a long time, finally liquid का temperature क्या होगा? 0 or T naught, huh? It will become T naught, right? Heat will stop flowing, no? So this temperature and this temperature will become equal. So if I put T is equal to infinity in the options, I should get T naught. Yeah. Make sense? Mostly you'll be able to eliminate 2 options. If you're lucky, you'll get 3 options eliminated, but advanced paper में नहीं होता है. At least 2 options will get eliminated. You have to solve. But can you guess how will the answer look like roughly? Look at this thing, huh? Listen to this statement, what I'm saying. This is important. This you encountered before also. This will keep on encountering. Look at the statement here. Because of the temperature difference, heat will flow out. If the heat flows out, temperature will decrease. If temperature decreases, less heat will flow out. If less heat flows out, then temperature will decrease even at a slower rate. Then even lesser heat will go. Then temperature decreases at an even a lower rate. Did you see what is happening? The function is killing itself. More heat flows, lesser the temperature, less heat will flow, lesser the heat flow, lesser the temperature. The function is killing itself. These kind of functions are called decay functions. Exponential, right, Poroja? You get exponential, e power something में आएगा. You know, where did we encounter this before? Anyone remember? Circular motion में किया था हमने question ऐसा. This question. Look at this thing. Who is providing the normal reaction on the wall? Centrifugal force, no? N is mv square by r. And friction is mu into n. So if you have more velocity, again, listen to this statement. If you have more velocity, you have more normal reaction. Agreed? If you have more normal reaction, you have more friction. If you have more friction, you have more deceleration. If you have more deceleration, your speed will decrease. If your speed decreases, normal will decrease, means friction will decrease. Did you see what happened to the function? The function is killing itself. Lesser the speed, lesser the normal, lesser the normal, lesser the friction, lesser the friction, lesser the acceleration. So speed will decrease even less. The function just repetitively kills itself. These kind of functions are called decay functions. And what is the answer? E power minus mu theta. Whenever you have a decay function, the answers are exponential. That is one way to say like, yeah, answer E mein hoga, E power something. Generally, 99% it works. Exceptions are there, but yeah. Then, so this much you can, figure out even solving the question. This is what I was saying. Just because your subject is very good doesn't mean you'll be able to solve the paper easily. That is a difference. When you think about different possibilities, did you see even before starting the question, we are trying to think what can be done, isn't it? This is what I'm saying. Instead of going and focusing on doing 100 questions, do 50 or 60, but try to think this way. This will actually help you more than going and doing 4 to 5 different books. This is how you make your subject strong. You, after solving the question, think, okay, what can be done? Is there any other way to do? Why did I do like this? What happens if I try like this? That is important. That self-questioning and doubting is important. Exam I won't be there to help you, right? The only person who can rely on yourself in the exam is yourself. So you need to ask yourself questions. Now try. I'll give you a minute or two. Think for a minute, then I'll give you the, like I keep saying, whenever you have to integrate something, what you do after time t, draw the situation and then try. So let me give you an idea there. So after time t, let temperature of the liquid be T. So in time dt, so it's small time dt, let dq heat flow out. So this will become T. So here dq heat is flowing out. Agreed? Now from calorimetry, what is dq? dq is equal to m into s into minus dt. Why minus? Temperature is decreasing. This comes from calorimetry, everyone. So whatever the heat is being lost by the liquid has to go somewhere. That comes from conduction. dq by dt is equal to Ka. Initial temperature is T, final temperature is T naught by L. This comes from conduction. Dimensions थोड़ा messed up है पुरुषा तेरा. And e power minus आएगा वो. I think you forgot the minus in that dq. Got it? Now take this dq and substitute here. So this is minus ms dt by d time is equal to Ka by L T minus T naught. This is dt by T minus T naught minus Ka by MSL dt. Integral, this temperature will go initially from 2T naught to T. This will go from 0 to time. That will be ln T minus T naught by 2T naught minus T naught. I substituted the limits also. This is minus Ka T by MSL. Shifted that side. T minus T naught is equal to T naught into e power minus Ka T by MSL. There, as expected, exponential is there. So T is equal to T naught into 1 plus e power minus Ka time by MSL. Advanced methods people are smart. What they will do, they'll give two options, e power minus KAT, e power minus 2 KAT. You're dead. You can't guess that. That's why you should know how to solve. Maybe mains में फिर भी थोड़ा guess कर लेंगे, but advanced में they will slaughter you. Pretty difficult to guess on advance. Have a look at the steps. So basically it takes infinite time for the temperature to drop. Clear? Next one. Let's say it's Russia, pretty cold, winter is starting. So we have a big lake. Suddenly temperature outside became minus 10 degrees. What will happen? The temperature of the lake also will become lesser. It will reach 0. And then what happens? Ice will start forming. Isn't it? So density of the water is rho. K of ice. This guy becomes 0 degree water. Latent rate of fusion is LF. So if you leave it for some time, you will start noticing the entire surface, ice will start forming. You start getting an ice slab. There is still water there at the bottom. So basically this ice actually hinders the heat flow. But remember, outside the temperature is still minus 10 degrees. Here the water is 0 degrees. So heat is starting, flowing from the water to ice. So this X is the thickness of ice. So find the thickness of ice as function of time t. Initially T0, there is no ice. As the water starts freezing, more and more ice will form. So the ice will start accumulating. It forms a slab of ice on the top. Temperature drops to -10 degrees and ice forms on the surface. Find thickness of the ice slab, that is x as function of time t. And since we know density of ice is less than water, it floats. So it'll actually be on the top only. There is no ice initially. The area of the lake is not given. It won't depend actually, that gets cancelled. How do we start? Ice will be obviously at 0 degrees, right? Until unless all the water freezes, you won't get lower temperatures. Remember, ice temperature can't drop until everything becomes ice. The lake is still unfrozen, right? There is still some water. Start like that. After time t, let the thickness be x. Let the dq heat flow out. Let the ice thickness form dx. That's how you always start. Think. I'll give you a minute or two. So we have the ice here. Let this be k. So in time dt, let a dq heat flow out. And a dx thickness of ice form. So for every small heat, small thickness will form. So what is the mass of this ice? The mass of the ice that forms is density of ice into area into dx. Agreed? To form this much ice, how much heat do I require? dq is equal to m into dm into lf. So that is rho A dx into LF. This comes from calorimetry, everyone. And dq by dt, this comes from conduction, is Ka. Temperature difference is 0 minus of minus 10 by thickness x. So here what is variable? The length of the ice slab, the thickness of ice. The thicker the ice, the more difficult for the heat to flow. So this is rho A L dx by dt. This is 10 Ka by x. A cancels. We get x dx is equal to 10k by rho L dt. Integrate this 0 to x, 0 to t. We end up with x square by 2 is equal to 10k time by rho L. Interestingly, if you see, t is proportional to x square. So the time is proportional to the thickness square. Means it becomes more and more difficult for ice to form. So you know how they'll ask in the exam? For example, if you ask you the time taken from 0 to 1 meter thickness of ice, if this is T naught, then the time taken to go from 0 to 2 meter thickness of ice will be how much? 4 T naught, na? Can you see? It becomes more and more difficult. For 1 meter, if it takes 1 hour, then 2 meters will take 4 hours. That means the time taken to go from 1 meter to 2 meter ice is 3 T naught. So from there, actually, you can get a ratio. 1 meter, 2 meter, 3 meter, you'll get a ratio 1 is to 3 is to 5 is to 7 is to so on. So as the ice thickness increases, it becomes more and more difficult to form ice. This is the reason why when if it is even a severe winter, right, in northern hemisphere or southern hemisphere, even if the temperature drops to minus 40 degrees, the lakes don't freeze. Maybe you will get something like half meter thick of ice. The fish are still surviving at the bottom of the lake. If the entire lake freezes, what will happen? All the fish would die. By the time the summer comes, ice will melt and again everything is back to normal. And this is the same reason why in an ice age, when the winter lasts for 10, 20,000 years, oceans don't freeze to ice. It takes a lot of time, but actually something else happens with oceans. Is this clear? That would be a good question in the red one. Find the ratio of time taken for first 1 meter and second 1 meter. That would be a mains question, 1 is to 3. So actually what happens in a ocean or a lake is this. This is just a theory. But you listen this. Formation of ice in a lake or an ocean. I'll just say lake. So let's say outside the temperature drops, the lake starts freezing. We get an ice. Minus 10 degrees. Let this thickness be x. Again, tell me one thing. Let's say when the outside temperature becomes minus 10 degrees, what will happen to the water? Let's say water initial temperature was 20. 20 becomes 15. 15 becomes 10. 10 becomes 4. And then what happens at 4? Water has maximum density. That means at the bottom of the ocean, what is the temperature of the water? 4 degrees, na? It's not 0. The bottom of the lake or bottom of the ocean, the temperature is 4 degrees. Socho na, if the water at the bottom is 0 degrees, won't there be ice at the bottom then? In all the videos you have seen, even in a marina trench, there is no ice. The 11 kilometers depth, you don't find ice. Water is pretty cold. You will freeze, but the temperature is 4 degrees. So the bottom of the ocean will have a 4 degrees thing. Again, you're talking about pretty deep. Four degrees max density. So the moment water reaches 4 degrees, it starts sinking. And now, interestingly, this 4 degrees is maintained by the thermal heat. This is the heat from the Earth's core. So this is what is happening. And what is ice ka temperature? This interface ka temperature is 0 degree. So heat is coming from the bottom to the ice, and the heat is escaping through the ice to the atmosphere. At some point, both will reach an equilibrium, and the ice ka thickness becomes constant. You're getting it? For example, if ice ka thickness is very small, what will happen? You will lose more heat. You will get less heat from inside. If the ice ka thickness becomes big, what will happen? You will get more heat from inside and less heat will escape outside. At some point, you will reach an equilibrium. So the heat coming from the bottom of the lake or the ocean to the ice slab must be equal to the heat that is flowing from the ice slab to the atmosphere. In reality, this is what happens. But the previous question will assume there is nothing like this. Everything is 0 degrees. So this will be K water, area, temperature difference will be 10, 0 minus 4 by length is d minus x. This will be K ice, area, temperature difference is 10 by x. If you solve this, you'll get x. This is constant. So ice ka thickness won't keep on increasing forever. This is the reason why oceans don't freeze to ice completely, even if the ice age goes for 1 lakh years. The thickest of ice that we know is in Antarctica. That's almost like 1 to 2 kilometers thick. And the time it takes to form them is almost 5 million years. 5 million years. That is 50 lakh years. It is that difficult to maintain, the thickness of an ice. Clear with this? There, with that, we're done with the conduction part. So next class, when we catch up, we will continue with the radiation. So that's also an interesting one. We have some pretty good problems on this. So do make sure to go through this. Whatever we did today class, there's a lot of integration involved. Right? You should definitely try all these questions without seeing them once, or else you won't remember them. Okay. That will wrap up for the day, right? Heat and thermodynamics is done. Conduction is also done. You should start solving whatever material you're solving. If you're solving your classes ka booklet, DCP, HCV, start doing it. Don't wait.